Hello everyone, in this video we are going to discuss a number theory problem. This problem has been taken from Tomato, the subjective part, and its number is 36. Let's discuss the problem. Let a1, a2, dot 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 an be n numbers such that each ai is either +1 or -1 if a1, a2, a3, a4, a2, a3, a4, a4, a5, and all these products till an, a1, a2, a3, that sum is 0, then we have to prove that 4 divides n. So there are many ways to solve this problem, so I'll be solving this using the invariance principle. The invariance principle is nothing but all you have to figure out is what is invariant in the problem. Then let's start solving the problem. So first of all, if I take that this sum is s, okay, we are letting that, okay, this sum is s, so then we can say that s is congruent to 0 modulo 4. And now suppose one of the ai's is negative. So if ai for some particular I is -1, then if we change ai to +1, then what will happen? So for that particular ai I am changing, okay. For example, you can take that, suppose for example a2 is -1 and we are changing it to +1, okay. Then how many products will be affected? So 4 products actually will be affected where a2 is present, and all those products, what is happening is their signs are changing, okay. So now let's try to figure out if suppose those 4 products where a2 was present, there if all those products were +1, +1, +1, +1, then when a2 I change it to +1, so basically I'm multiplying those products by -1 and nothing else. So all these gets transformed into -1, -1, -1, -1, okay. So under modulo 4, previously I was having +4 and which is 0, and now also I am having -4 which is also 0. And so in this case, suppose let's take that this is case 1. In this case also, after changing, so I showed the example using a2. So if this the same logic works for any ai. So any particular ai which is -1, if you change it, that particular ai, just if you change it to +1, then my claim is that s will still be the sum won't change under modulo 4. So in this case we saw that s is still congruent to 0 modulo 4. Now let's take case 2. Suppose 2 of them were plus and 2 of them were -1. Then what will happen? Again the change will be like 2 of them will get -1 and the other 2 will get +1, okay. So in the previous case this sum was, so suppose if the this sum, as you can see, it's 0, okay, and here also this sum is coming out to be 0 again, okay. And so again overall, like yes, it would be unfair to write s all the time. So when I'm changing the ai, that is that particular ai from -1 to +1, then let's say that it's s dash, okay. So in this case s dash is congruent to 0 modulo 4, and again s dash. So s dash is nothing but the sum of these where I have just changed that ai which was -1 to +1, and still this is congruent to 0 modulo 4 in this case. Now let's think what could be the other cases. So case 3, now there could be 1 plus sign and all the others could be -1s. And so when I change it, so it changes to -1 and all the others +1s. Now let's see. So in before it was +1 and 3 -1, so -2. So -2 under modulo 4 is also 2. And here, as you can see, when you're changing those plus to minus and minus to plus, so then also in the sum, that particular part, it's not changing under modulo 4. Okay, so that particular, so the remaining things remains the same. That very particular part under modulo 4 still remains the same, it's 2. Okay, so this part, as you can see, it's congruent to -2 modulo 4. Okay, which is basically 2 modulo 4, and this is congruent to 2 modulo 4. Okay, and thus in this case also S dash is congruent to 0 modulo 4. Okay, and what could be the fourth case? Just one negative sign and all the other plus signs. So even in that case, -1 +1 +1 +1, this changes to +1 -1 -1 -1, and so as you can see, this part is 2 congruent to 2 modulo 4, and this part is congruent to, after the change, this part is congruent to -2 modulo 4. And so again, as a whole, that part under modulo 4 remains the same, and so S dash is congruent to 0 modulo 4 in any case. Okay, so what we just saw is that if we are changing this sum S to S dash by changing a particular value, a particular -1 to +1, then we see that still S dash or the new sum is congruent to 0 modulo 4. So again, suppose now our new sum is S dash. Okay, now I can keep on doing this. So whatever be the other negative sign in S dash, now I'll pick up if there is another negative sign or -1, I'll pick that up and make it +1. And in a similar fashion, I will be able to show that S, suppose let's call that S double dash, that would be congruent to 0 modulo 4 again, because that's what the invariant is, because that's not changing. If I change a particular -1 to +1, the sum under modulo 4 is not changing. And thus, if you keep on changing all the -1s to +1s, you see that there are n such products. Okay, and if all the AIs are finally positive ones, so each of those products will be +1, and thus the sum will come out to be positive n. And thus we are finally, since still then also it would be congruent to, it would be still then congruent to, so I'm changing all the -1s one by one to +1s, and thus I'm getting finally n, and that should be congruent to 0 modulo 4, because the sum is invariant under the sign change of this minus sign going to plus sign under modulo 4, and for that reason you have n is congruent to 0 modulo 4. So we have proved this, and that's it for this video. See you in the next one. Thanks for watching.